All right, this is Mr. Garner here. This video is meant to get people caught up if they missed Thursday or Friday in Miss LeBlanc's class. We didn't move on in Friday if you weren't there. We pretty much just recovered this because the Thursday presentation was sort of non-existent. Yeah. So let's go ahead. If you need to see this, what I want to do is just chat a little bit about the notes on page 6 and then do a few problems on page 7, and hopefully you'll be good to go. So these are a couple of ways to find areas of a triangle, and this is in addition to the famous area equals 1/2 base times height. There are two other ways. The first way is Heron's formula, which you're looking at here at the top. And let's see, it's this. And it's a two-step process. First of all, it's meant for any triangle that is only providing you with information about the sides. So we don't know that angle, we don't know that angle, and we don't know that angle. Okay? We don't need to know them for Heron's formula. The first thing we need to do is calculate this value s, which is just 1/2 the sum of the given side values. All right? So here it would be 1/2 9 plus 7 plus 5, whatever that is. And that'll provide you with the value of s, which then goes into your main formula here to find area of that triangle. And so it's the square root of s, and then the same s value minus the length of side A, then again the same s value minus the length of side B, and finally times the same s value minus the length of side B, and then take the square root of it, and you're good to go. All right? So, if you have a triangle that's only has information about sides, you're going to want to use Heron's formula. Okay? Now, the other thing that we looked at was provided by the law of sines. Now, I think in class I said this was another variant of Heron's law. It actually isn't. I'm sorry. That's my bad. This is something we didn't cover in KAP when I taught it. And so, sorry about that. I just thought the two were of the same thing, but they're clearly not. All right, so law of sines is the second way to do it, and you're still working off of formulas. You don't have to derive anything. And this is where you don't get all three sides. You notice that side C here does not have a length. All right, but we are going to need to know what one side is, another side, and the included angle. So just for fun, let's say that that's 50 degrees. All right. If you get something like that with two sides that make up a vertex with the angle measure for that vertex, then you want to use this law of sines. Okay. And to me, there's only one of them, because when you see this, you're just going to have a given side times 1/2 times sine of the angle in between. All right. And it looks a lot like area equals 1/2 base times height. And if you actually, look at a given triangle and you work it either with this approach or this approach, the two are the same. Okay? So it's kind of neat. It's just a trig sort of interpretation of our, standby geometry formula. Okay? So what I'm going to do now is just kind of go ahead and pause this, and we'll proceed to work some formulas on the next page. All right, so here's page 7, and the homework assignment was mainly odd number questions, except I believe the last 4 on the page here, you had to do evens and odds, 19 through 22. So what I want to do, I picked a few of these to do, and I'm going to pretty much just, I'm not going to stay on this page really, because there isn't any room to work. So you might want to just go ahead and get out your packet and circle these because these are the ones I'm doing. I'm going to do number 2. I'm going to do number 4. I'm also going to do number 6 here. Number 14. Number 18. And finally, this is one I did in class, but if you weren't there, clearly you didn't see it. I'm just going to go ahead and do number 22. Okay? Oh, check that, 21. So I'm going to pause this again and get, because like I said, I can't really work in this confined space. So you won't have this to look at as I work. So have your copy handy in case you need to glance down and see. So I'm just going to go ahead and pause. Okay, so back at it here. This is number 2, and the information along this line here is what was given, the measure of angle A and the lengths of sides B and C. And I spared you guys having to watch me write this all out. But always make a triangle, kind of put in the detail so that you can figure out, what formula to apply or how to proceed or whatever. While I'm thinking about it really quickly, if I'm tedious and boring, certainly you can hit 1.5 times speed or double speed, and I actually sound a lot better. Or you can say, I don't really need to see any more examples of this. I'm going to move on and just skip over to the next example. So it's up to you. You can certainly make this a lot shorter. But we're supposed to find the area of this. Okay? And since I've got a side and an included angle, that looks like not Heron's rule or formula, but the other derived from the law of sines. So this will be 1/2 times 11 times sine 34 degrees. And you just need to put that in your calculator and you can pop out the answer. All right, and the answer happens to be 33.83. Don't forget to put units on there, even if it's generic, so that's in square units because that's what area is. Now this had told us to round to the nearest tenth, all right? So the nearest tenth is this place right here. The value before it is less than 5, so this is asking us to round it to about 30 square units, okay? So that's problem number 2. When you don't have one with Heron's formula, it goes pretty fast. So hold on, and I'm going to switch over to number 4. All right, so here's number 4, and again, I've written it out. But I didn't draw the triangle because I kind of want you to see what's going to happen with this one. So the measure of angles B and C are 60, and side A is 10. So, regular old triangle that just about every problem has. So A, B, C, side A, side B, side C. All right, so angle B is 60, angle C is 60. All right, now you're starting to see something going on here because that adds up to 120, and if you take that from 180, that's going to make this also 60 degrees. And so this is going to be an equal angular and also equilateral triangle. So if A is 10, then B is going to be 10, and then C is going to be 10, and so that makes things pretty easy there. So we're still needing the area here. So area is going to be 1/2, and I guess we only knew, go away. Okay, we didn't actually know this, and we didn't know this, and we didn't know this. Well, okay, we do know this. So because we do know that it's all equiangular and equilateral. So this is 10. This is going to be 10 here. and then sine 60 degrees. And so that makes it sort of easy. This is going to give you an area of 43.3 square units. And again, it's to the nearest tenth, so that would be 40 squared units. All right, so let me pause again. All right, so on to number 6. And I've drawn this out. This was the information that was given. We had the measure for angle A, the measure for angle B, and the measure for angle C. Basically, what I want here is I want a value for B, all right? So that way I'll have this side, this angle, and this side, and I can use that law of sines approach for area. So this is what I definitely need. In order to do that, I don't have matches like angles with sides anywhere. So I'm just going to add these two together and subtract from 180 to get the measure of angle C, which should be 26.2 degrees. And so let's go ahead and do law of sines. So I'm just going to say that sine 26.2 degrees divided by 46.7 equals, let's see, sine 112.5 over B. Okay? And if you work this out, you end up with B equaling 97.7. All right, so 97.7, I believe. Okay, I've double checked this because I actually had it wrong the first time, so hopefully it's right now. So now we'll just use that formula based on the law of sines. So area will be 1/2. All right, this side here, 46.7, and then times this side right here, 97.7, times the sine of the angle that's sort of formed by the vertex, sine of 41.3. And so when you're all done with this, you should get 1,505.7 square units, or since we have to round to the nearest tenth place, it'll be about 1,510 squared units. Okay? So pause again and we'll just keep going. Okay, so here we are with problem number 14, and you'll note that we have no angle values or angle measures given to us. So this will be Heron's law. All right, so we're going to have to start out getting that value for S, which is, remember, 1/2 the sum of all three of these side measures. So it's 1/2 times 18 plus 24 plus 30. And I believe you should get 36. Okay, so that's your value for S that we then put in this other formula. Remember this one? S times the quantity S minus A times the quantity S minus B times the quantity S minus C. Get that product and take the square root and you get the area. Okay? So the area will be the square root of 36, that's this S here, times 36 minus 118 times 36 minus 24 times 36 minus 30. Okay, oops, still under the radical here. So when you do all of that math, you get that your area is 216 squared units, or since it's to the nearest tenth, it will round up from the place before it. That'll be about 220 squared units. Okay, so pretty easy. A little busy, but pretty easy. So let me go ahead and pause and we'll keep going. All right, so here is number 18. This is next to last, and they've got a little bit of a wrench thrown into the works here. They gave us all three of the side lengths, 50, 48, and 26, and I have them labeled. But they want us to find, of all things, the length of the altitude from vertex A down to side CB, all right? So it's, we just drop a perpendicular down to this side. That's why I marked it at a 90-degree angle. They want to know this length. And you're thinking, yeah, right. They didn't give us a formula for that. So you kind of have to work with what you have. And it's not as bad as you might think, because if you can get the area, then you can use that area to work backwards through 1/2 base times height, with the height being the same as the altitude. You'll see, okay? So since we have all three sides, this is Heron's law. So we got to start out getting that value for S, which is 1/2 of the sum of all three of these values, 48 plus 26 plus 50. And that should give you an S value of 62, all right? So this is going to be used in the bigger formula for altitude. It was in the previous problem, so I'm not going to write out the formula. It's just going to be the square root of that value for S, 62, times the quantity, 62 minus 48, times the quantity, 62 minus 26, times the quantity, 62 minus 50, okay? And take the square root of all of that, and you should get that the area is 612.3528. Okay, since that's really not what we're looking for, I gave it a few extra decimal places to try to improve the accuracy, okay? So let's see what we've got, all right? That is your area, which equals 1/2 your base times the height, okay? So if we can get this, that should be what our value should be. So area is going to equal, well, we don't actually need that. Let me substitute in 612.3528 equals 1/2 your base. Let's just call this, let me change the color here. We'll call this the base. All right, so from C to B is going to be 48. So let me get back to the green. Times your height, right? Well, 1/2 of 48 is going to be 24 times your height, and that equals 612.3528. And divide each side by 24. And so your height, see, I kind of switched from regular script to this script for altitude, is approximately 26 units. Okay? It's that simple. So you get the area, and then you go back to our old standby geometry formula, and you just dig out that height, which is the same as your altitude. All right? So that brings us to the very last one. I'm just going to repeat problem number 21, which I did in class. So let me just pause and set that up. Okay, this is the very last one. It's number 21. And we're supposed to find the area of this quadrilateral. And it's irregular, so we don't have any formulas for it. So the key here, or the trick, is going to be to split this thing into two triangles, okay? And it won't make much sense. I mean, we're going to have to draw a diagonal either from A to C or from B to D. Since we only have one angle at 46, it really doesn't make any sense to try to do a diagonal through that angle, because then it splits it into two angles, and we will never ever know the measure of each one, and it's just going to take away any kind of useful information we could have had. So I'm going to draw a diagonal from C to A, and let's see if I can do this nice and straight. All right, something like that. Okay. All right, now the good news is, well, let me just, before I talk about good or bad news, we're going to have an upper triangle, kind of this one, from A to B to C, right? And then a lower triangle from A to C to D. And if you look at the upper triangle, we have a side that gives us a length, and we have another side which gives us a second length, and the included angle is given also. So since we're trying to get the area of two triangles and add them up, the top one is going to be that law of sines version, which, by the way, is the easier of the two. So let's just start out. Whoops, that dropped. Let's get it up here where you can see it again. So we'll do the top in, let's just do it in green. And so the top, that area will be equal to 1/2 43, that's this side here, times 97, which is this side here, times the sine of that included angle, which is 46 degrees, and that'll give us a value of approximately 1,500.18 or thereabouts. Now the rounding is to the nearest hundred, so we're going to lose that little piece of detail. But this is done. We don't need to figure that area out. Now we need to figure out the bottom area. Now if you look at this triangle ACD in the bottom, it has no included angles, no information about the measurement of any of the angles. So it looks to me like we're going to have to use the two sides, and we kind of need, let's go ahead and we'll do this in pink, we kind of need how long from A to C is, all right? So I'm just going to call this, I don't know, little c. You know, I know it's not going to be any kind of a proper labeling, but I need to call it something, so we'll call it that. So we'll start out with, you know, we're working on the bottom, try to get that squared away. And since, you know, we don't have any angles here, we're going to have to get C from this top triangle, okay? So the way I'm going to do it is with the law of cosines. So C squared equals 43 squared plus 97 squared minus 2 times 43 times 97 cosine of 46 degrees. All right, since that's the angle that we have, and that should be able to give us what C is. All right, and of course you're going to have to take the square root of all of that to get rid of that exponent. You're going to end up with C, when you're all done, equaling 73 point, I have 91. So C equals 73.91. And now that's the same, it's a shared side, so we now have this, this, and this for our Heron's rule, okay? So we'll start out by getting S. Remember, that's step one. So that would be 1/2 51 plus 29 plus 73.91. And that will give us approximately 76.955. Now you may be able to do some rounding and get the numbers a little cleaner, like you could do 73.9 or even 74. I'm just trying to get a little bit of accuracy, which, by the way, since this problem needs to be rounded to the nearest hundred, my efforts at trying to get accuracy are going to kind of be wasted, but whatever. Okay, so this is going to be S. So the area that we need is going to be this big long formula. That's going to be 76.955 times the same, 76.955 minus 51 times same, 76.955 minus 29 times, finally, 76.955 minus 73.91. And I didn't even draw it long enough, this radical sign. So there you go. When you get done with this, you know, do all this multiplication and subtraction and whatever, and take the square root, that's going to give you about 544.38 or so. And if I go ahead and add 1500.18 to that, all right, that's going to be 16, carry the 1, so that'll be a 5, and then bring down a 4, bring down a 4, and that'll be 2044 units squared. But they want us to round it to this place, so, or it's about 2,000 square units. All right, so that had a lot in it. It had the formula from the law of sines, it has the law of cosines, and it has Heron's formula. So it's got just about everything you could want. All right, so that's kind of what you missed. The assignment is all of the odds up through 17, and then the final 4 are all like this one. All right, so on that note, I'm going to finish, and thanks for watching.